Good evening and welcome to Power BI Manchester February 2022. It's good to see everyone this evening. Welcome to our online viewers. My name is Alex Taylor and I work for Robert Walters. We are now in our 5th year of Power BI Manchester Meetup. We've now got in excess of 3,000 members on Meetup and 7,000 on LinkedIn. So it's a fantastic community, and thank you to everyone that's been involved over the last 5 years. A little bit about me. I'm a data recruiter alongside Chris and the team. I've been recruiting for 18 years, so I'm long in the tooth. I was quite young then. That was 3 years ago at Seagull Bits, which is back this year in London. Unfortunately, I won't be attending because I've now got a second child, which is keeping me busy. But yeah, it's a fantastic event. But if you are looking for a new job, looking to recruit, or know someone's looking for a new job, please ask them to get in touch. Myself, Chris, and the team will help you. Tonight's event will be a brief intro for myself. I have swapped around this talk, so Nikola's going to go on first. So Nikola is dialing in remotely from Austria, and then our resident co-org, Ben, will be speaking at about 10 to 7, and we've got Dominoes for everyone present at about 7:30. Ben is a model for regatta crag hoppers, and now he's the Castle, was it? Okay, fair enough. Ben is a Power BI expert and project expert for over 25 years. He has been part of the group for 5 years alongside myself, and he is now in his 13th year as a Microsoft MVP. Is that right? Yeah. And Nikola, who is joining us remotely. So I'll be passing across to Nikola in a moment. He is over in Austria. He likes to be known as Data Mozart. He is a Barcelona fan for his sins, so he's going on first so he doesn't miss the match, which kicks off at 8. And so yeah, we are doing some training at this office in 4 weeks' time with Ben and a few other guys. So if you're interested in attending training, do get in touch with myself or Chris. We're doing Dashboard in a Day session on the 24th of March. And we're also doing Power App in a Day with Dave Scally on the 9th of April. So there are limited places available, one attendee per client. So do get in touch if you are interested in attending. And without further ado, can we move over to I thought doing like on Eurovision, like Vienna?
Not Vienna, Salzburg.
Salzburg, sorry. Hi, Nikola.
No problem.
How are you?
Hi. I'm fine, thanks. And you?
Very good, thank you.
Good. In fact, I'm closer to Munich than to Vienna, but it's still Austria, yeah.
So you are now presenting to about 30 attendees in Manchester.
Awesome.
So without further ado, I'll pass you over. So good luck, and I'll speak to you later. Cheers, Nikola.
Thanks. So hi everyone. Good evening. Greetings from Austria. Yes, I'm still happy to be part of this event, even though I couldn't join you in person, but hopefully next time I can be directly here with you in Manchester. So before we start, let me just briefly introduce myself. My name is Nikola Ilic. I'm originally from Belgrade in Serbia, but for the last 6 years, I live in a wonderful city of Salzburg in Austria, where I work as a manager analytics in Avanade, joint venture company from Microsoft and Accenture. Living in Salzburg was the reason why I've chosen this nickname Data Mozart, so it doesn't have anything with my passion about classic music or something like this. It's just because I'm living in Salzburg, and Salzburg is worldly famous as a birthplace of Wolfgang Amadeus Mozart. You can find me on web. I'm blogging at data-mozart.com. I'm also active on social media, LinkedIn, Twitter, so feel free to connect if you like. Other than that, I'm Microsoft Data Platform MVP, Microsoft Certified Trainer, and also authored some courses on Pluralsight. Privately, father of 2 kids, and as Alex said, true Barca fan since 90s. So thanks for making the space for me to be first tonight, so I can watch the game later. I really appreciate it. Okay, so let's start. And let me be honest with you, creating a Power BI report may look like an easy task, So you import the data, you set those nice colorful visuals, everything is fine, and your shiny dashboard is ready. However, one day you get a phone call from the report user who complains that Power BI report is slow. Or what's even worse, your scary old DBA walks into the office and asks you to explain why your report burns all the available resources during the data refresh process. Or no one comes to you, but your report simply sucks in terms of performance. As I've already told you, building a Power BI report is not a rocket science, but there is a huge difference between a Power BI report that works and Power BI reports that works efficiently. Now you're probably asking yourselves, if I have performance issues in Power BI, where do I start? And that's a great question, because once you identify the area that causes problems, you are halfway through the solution. Okay, maybe not halfway, but you can then shift your focus to finding a solution to a more specific issue. With that in mind, there are at least 5 key areas to examine if you want to improve the performance of your Power BI reports. So those 5 areas are data model size, data refresh process, DAX calculations, visualization rendering time, and storage mode choice. So let's go and now try to understand each of these areas in more detail. First thing I would like to discuss is your data model size. It is so important that in certain scenarios, for example, when you are operating on Power BI Pro license, which has a 1 GB limit per dataset, your solution simply can't be used if you reach that limit. Data model size also affects our second talking point, data refresh process. As you may assume, the larger the model, the more time and resources is needed for the data refresh. Basically, tabular model speed is based on keeping data in memory, so in cache memory. Thus, the smaller the memory footprint of your data model, the faster it will be. Now, to understand what affects your data model size, we need to lay some theoretical background. First of all, when you choose import mode for your data in Power BI, data is being stored in a columnar database called VertiPack. What VertiPack does for you, it keeps the snapshot of your data in memory. And this snapshot can be then refreshed periodically from time to time from the original data source. So to understand how things work in the background, you should be able to distinguish between two core components of the VertiPack engine. Those 2 components are formula engine and storage engine. We'll not go deep into explaining this, just for you to be able to understand what is happening under the hood. Basically, formula engine represents the brain of Power BI because it is able to translate your DAX queries to a specific query plan that consists of different physical operations, for example, joins or aggregations, filtering, and so on. On the other hand, storage engine is the sporty one, the muscles of Power BI, because it literally physically goes through the data which is stored in the tabular model. So in the end, if storage engine needs to dig through massive amounts of data, it would obviously need more time and resources. And I'll try to give you a simple analogy. Imagine that you have to find a book in your old attic. What do you think? Would it be faster and easier to find it if you have just a few items around, or if your attic is in complete mess and full of all kinds of stuff? I think you know the answer. So optimizing data model size is a wide topic. I have a separate session, 60-minute session dedicated just to it. So let me just here list best practices related to data model size optimization. First one is reduce the amount of data you're importing in your data model, and keep only those rows and columns your users really need in the report. That means remove unnecessary columns. Also, that's called vertical filtering, so removing unnecessary columns. How do you do horizontal filtering? Removal of unnecessary rows. If you don't need, or your users don't need data from last, I don't know, 10 years, but only 2, then simply filter out unnecessary data and don't import it in Power BI. Next, also very important one, try to reduce column cardinality whenever possible. Column cardinality stands for the number of unique values within the column. And in most cases, because VertiPack compresses the data once it's loaded into Power BI. So the lower the cardinality, VertiPack will create a smaller dictionary for those values, and consequently, this will take less memory in your data model. So to make it simple, if you don't need data on a, let's say, level of granularity lower than day, then remove hours, minutes, and seconds. So that will significantly reduce the size of that column. I will show you in a few minutes in one example what I'm talking about. Then also avoid using calculated columns whenever possible. They are not being optimally compressed, to cut the story short. Instead, if you do some calculations, try to push them to a data source like SQL database, for example, or perform those calculations using Power Query Editor. Also very important one, disable auto date time option for data loading, as this will remove a bunch of automatically created hidden date tables in the background. Instead, always create a proper calendar or date dimension in your data model. So I want to show you quickly one of these points in action, and I will switch to Power BI Desktop. Okay, so I have a very simple data model here. It's not even model, it's one table, which has around 9.3 million rows. Okay, so nothing special, but my date team start UTC column goes to a second level of precision. And as you may see, I have around 9 million distinct values, so cardinality of 9 million. To be able to follow what is going on with data model size, I'm always using DAX Studio. And I hope that you're familiar with this fantastic free tool. If not, go to daxstudio.org and download it for free. It will make your life as a Power BI developer much easier, believe me. So one of the coolest features in DAX Studio is VertiPack Analyzer. So VertiPack Analyzer collects data from different dynamic management views related to your data model and displays them in a much more readable, more structured way. So if you go to Advanced tab here on the top and click on View Metrics, you will see different values here, different metrics. I will not go into detail explaining each of those. And if I click on this small arrow next to a table name, I can see all those numbers broken down on a column level. You see that cardinality of our date team start UTC column is 8.8 million, so almost 9 million. And column size, this is important. Column size is, those numbers are in bytes. So the column size is 454 megabytes, 454 megabytes. I just want you to remember this value. Now, if I go back to Power BI Desktop and let's go to Power Query Editor. Okay, just a second to put this properly. Okay, and I will get rid of those time portion here, this time portion here. So I will get rid of hours, minutes, and seconds. So I'll just change type of my column from date time to date, because my reports require a day level of granularity, and I will hit close and apply. Let's wait for a few moments for Power BI to apply those changes. It will take maybe 40-50 seconds, maybe around 1 minute. And then we will switch again to DAX Studio to check if this change of data type and reducing the cardinality brought some savings in our data model. Let me quickly show you again. So we have 454 megabytes now, 454 megabytes. Okay, almost done. Take a beer until we are waiting. Few more seconds. That's it. Let's just wait for Power BI to apply this. And these numbers, yeah, it's changed. So we have, instead of 9 million, we have just slightly over 1,000 distinct values. I'll go again to DAX Studio and again click on View Metrics to refresh this view. Let's expand it. And now you see that this column takes 6 megabytes, or let's say 7 megabytes. So instead of 454 megabytes, it's just 7 megabytes. So it's like 5-10% of the original column. So always try to reduce the cardinality. If you don't need so many, so detailed over data, reduce the cardinality, and that will significantly reduce the overall data model size. Okay, going back to our presentation. Now that you know how to optimize your data model size, your data refresh process will run much faster. And that's true, but not in 100% of cases. I mean, if it's simple like that, you know, you could drink a beer and I will not be there tonight. So as I've already explained in the previous part, Vertipack keeps the snapshot of your data in memory, and then you are refreshing this snapshot from time to time, depending on your specific business needs. It can be once per hour, once per day, once per month, and so on. Now, chances are that you are applying some transformations to your data before you load it to Power BI. That can be a currency conversion, data filtering, renaming your columns, performing some calculations, stuff like that. So where do you shape your data? Source database, that's the most obvious choice, and in most cases the most desirable scenario, which is based on those traditional extract, transform, and load ETL processes. If you are not able, for whatever reason, to apply your data transformation on the source side, the next station is Power Query. Power Query is the built-in tool within Power BI that enables you to perform all kinds of transformations to your data. Last time I checked, in Microsoft's official documentation, you can apply more than 300 different transformations, and that number is constantly increasing. So the key advantage of Power Query is that you can perform complex, really complex data transformations with little coding skills or without coding skills at all. Additionally, all steps that you applied during your data transformation process are being saved. So every time you refresh your data set, those steps will be automatically applied, and your data will be shaped and prepared for further consummation through Power BI reports. Under the hood of this Power Query thing is a mashup engine that enables this data shaping process to run smoothly. So Power Query uses very powerful M language for data manipulation. Now, for some data sources, such as in most cases relational databases, but also for some non-relational data sources like OData, like Active Directory, like Exchange, mashup engine is smart enough to translate M language to a language that this underlying data source will understand. In most cases, this will be SQL. What are the big news about this? So by pushing those complex calculations and transformations directly to a source, Power Query takes advantage of those powerful, robust relational database engines that are built to cope with large volumes of data in the most efficient way. And that ability of Power Query's mashup engine to create one single SQL statement that combines all your M statements behind your data transformation is what we are called query folding. Or let's make it simple. If the mashup engine is able to generate a single SQL query that is going to be executed on the data source side, we say that the query folds. Query folding is an extremely important concept, an extremely important feature in Power BI, also deserves a separate session. However, we don't have time for demo because it takes some time to demonstrate the difference in performance of data refresh process with and without query folding. But I will tell you that on one simple table from this sample Contoso database that has 12.6 million rows, the difference is that with query folding, data refresh process takes around 30-40 seconds. Without query folding, it takes 4-5 minutes. So just imagine the implications on the larger data sets. That's why it is important to always try to achieve query folding. Okay, so again, listing all the best practices related to data refresh process would be a complex task. Therefore, if you identify that your data refresh takes, eternity to execute, maybe it's a good idea just to check it. And the first thing I'm going to recommend here is fantastic blog post written by Phil Simak from Microsoft's Power BI customer advisory team, where he explained how you can visualize your whole data refresh process and quickly identify potential bottlenecks. Awesome, check this, please. Other general best practices in order to speed up data refresh process in general and keep query folding in place are the following. So first one, the most important one, push calculations and transformations as close to a data source as possible. For example, if you have a permission to create a database objects, you can encapsulate all the necessary transformations within the view, and then you can import that view in Power BI. Views, same as regular tables, are foldable objects, so you can even apply additional transformations over those views when you import them in Power BI. Also, query folding is not all or nothing operation. That means if you have, let's say, 8 transformation steps within Power Query and your query folds until 5th step, you will still get some benefit from partial query folding. However, once the query folding is broken, it can't be achieved anymore. Keep that in mind and try to push all non-foldable steps down the pipeline as much as possible. What I'm talking about, if you identify that this step breaks query folding, move it here, move it down. So all the previous steps will fold then. Okay, this one also important in some circumstances. Turn off allow data preview to download in the background. Why should you do this? So when you are in Power Query Editor, you see preview of the data for every transformation step that you applied. So when you hit the refresh, it's not only the amount of data that gets loaded into your data set itself, but also a whole bunch of different queries to refresh this preview. And in some situations, these queries take more time than loading data itself. Just one disclaimer here, this allowed data preview to download, that's happening only in Power BI desktop, so not in service. If I have to choose one single rule regarding data refresh process, and let me call it a golden rule, that would be this one. It's not mine. I picked that up from Matthew Roche, also from Microsoft. Push your transformations, set calculations as upstream as possible and as downstream as necessary. That's famous Roche's maxim, so keep that sentence always in mind. Okay, now hopefully we are done with the background scenes and we are slowly navigating to user interface. And honestly, this is the area of Power BI where performance issues are the easiest to identify. And I'm sure that, you know, we have all been in that situation. Sooner rather than later, someone will come to you and say, hey, why is my report so slow? Of course, there can be a whole bunch of potential reasons, but let's try to focus on a few that are most often guilty for the bad user experience. So first one, DAX calculations. Once you import the data in Power BI, I assume that you will start writing DAX measures to satisfy different business requests. For example, you need to provide your users with the metrics such as the number of unique customers, top performing products, running total of the sales amount, and so on. The beauty of DAX, and I intentionally put this word beauty under the double quotes, is that you can achieve the same result in multiple different ways. I will definitely not go deep into DAX logic in this session, explaining filter context, context transition, and so on, as there are many people around that who know DAX much better than I will ever know. However, there are a few certain situations where really little nuances in your DAX formulas can take you in the direction that you wish to avoid. So let me quickly show you. This is a quick demo. Again, I will go to, or we can do it in DAX Studio. So let's spin up a new instance of DAX Studio. And since we are a little bit limited with time, I will not type the measures in DAX Studio. I'll prepare them in advance and I will just copy paste. I will turn on server timings on the top just to show you the difference in performance of those two queries. And I will first clear cache and then run my measure. Let me run it and then I will explain what this measure is doing. Okay, so I will sorry, this one. Again, I probably missed some brackets or okay. Let's try again. This one. Fine. And okay, I don't see what's the problem. Yeah, that's the beauty of live demos. sometimes it's, let me check. No, it's not a bracket. I measure value, calculate table, summarize columns. Sales amount. I really don't see what's the issue here.
Nick, can you hear me?
Yeah.
Yeah. So we got a load of people, about 40 of them, all debugging your code here.
Okay.
They've all
Okay.
put their glasses on. Somebody thinks it's the name of the table. Go on. So
Could be.
express that to me so I can express it to Nick.
Yes. Thanks. Beer for that person who spotted.
Beer for that person. Great. They're both pissed already.
Thanks. Yeah. Let's do it quickly. Thanks for that. Yeah, that's happening when you are copy pasting code. Don't do it. Don't be lazy. Okay, I think we are good to go now. Not yet. Here. Oh, yeah. Okay, so what is happening here? First of all, thanks for the hint. We ran the query. We want to display only those sales where sales amount is greater than 500. So basically, we are using distinct count to calculate sales order number, distinct sales order number, and we are filtering data from our online sales table. What's the problem here? In filter function, basically we are providing the whole table as a first argument. So DAX engine will materialize for each date in our data set. It will materialize a result set, and that produces our like 40 something seconds so far. Hopefully this will be finished soon. Okay, yeah. So you can immediately imagine that something is wrong with this measure. It couldn't, yeah, it's 57 seconds. In the end, if I go to server timings, let me zoom it a little bit, and you see that this query took 57 seconds to execute. We have 1,000 and almost 1,100 storage engine queries. So for each date, we have a separate storage engine query. That's problem because we have materialization for each date. Now, what I can do if in this case, if I just use filter and remove all active filters from my online sales filtered column, let me just grab this one. Sorry again for copy pasting, just to save some time to be able to cover everything. So this one is filtered. And okay, and here also. And I think that's it. Yeah. So let's see this other measure, which is quite similar. So we'll get the same results, but now instead of 57 seconds, we have 137 milliseconds, and we have just one storage engine query. Basically, we removed all the filters just from one column and kept only this filter that keeps those rows where sales amount is greater than 500. Same results. Instead of 57 seconds, this one is in 137 milliseconds. So the moral of this story is when you're using filter function, always filter columns, not tables. That's the main conclusion here. Next one, visual rendering time. This one is also very interesting. This is the most obvious problem. Yeah, because when your report page is rendering slow, you can bet that the report consumers will complain about the poor experience and ask you to do something. So let's check what can be a root of the slow rendering time. First of all, Power BI offers you a very handy built-in feature which is called Performance Analyzer. Performance Analyzer enables you to capture the performance metrics for every single visual element on the report page. The rule of thumb here is the more visuals you have on your report page, the longer time would be needed to render the page. And I will show you in a few minutes how this looks in reality. Let's do a quick demo. So here I have 10 card visuals, each of them showing different metric. Very, very basic calculations, some minimum, average, maximums, nothing special, nothing complex, okay? But I have 10 of them. Now, if I go to View tab and turn on my Performance Analyzer, start recording, and let's refresh our visuals. So I will sort this in by total time, and I want to sort in descending order, so I can immediately spot which element is the slowest one on my report page. And it appears that that's this one card, last sales date. Never mind. If you expand this single information, you can see how much time was spent on DEX query, visual display, and other. Now DEX query 40 milliseconds, that's fast. Visual display 7 milliseconds, it's also irrelevant. But this other takes 522 milliseconds, 90% of the total time. So what this other means? That's a good question. So let me answer it. Other means how long a specific visual had to wait in the queue for other actions to complete before this visual could be handled. Don't forget that Formula Engine works in a single threaded way, so it can't generate the DEX query for multiple visuals in parallel. Now this was an example. We had like 550 milliseconds. Let's clear this, and let me show you what I have here. I have exactly the same look and feel of the report page, but now instead of having 10 cards, I have 2 matrix visuals. So I spent some time to format this properly, to set all the properties to mimic the look and feel of this page. So we get exactly the same design. But now I will turn on start recording and refresh my visuals, and you see that now it's less than 200 milliseconds. So it's 4 times faster than in the previous case. Why? Because in this case, instead of generating 5 DEX queries for those 5 calculations, Formula Engine generated just 1 single DEX query to cover all of those. And that significantly improved the performance. Okay, that was demo. And let's now talk about best practices when it comes to visualizations and rendering of visualizations. So here is the short list of the things you should do or not do when it comes to performance of your visuals. First one is reduce the number of visuals on your report page. That's simple. If you don't need a visual, just simply remove it from the page. Also, if you have multiple non-data related objects such as text boxes, images, icons, so on and so on, that will also impact the rendering time. So if you plan to use a lot of them, consider using PowerPoint. Then you can, in PowerPoint, you can create your desirable page background design in PowerPoint, save it as a PNG or JPEG file, and then set this image as a page background in Power BI. So instead of having like 10 or 15 non-data related elements, you will have just one single image. Reducing the number of visuals on your report page also means that, like in our example, if you have a possibility to satisfy the business request by generating 1 DEX query instead of 5, you should tend to do it whenever possible. Next one, try to display data at high level of grain. Vertipec really excels in vertical aggregations, but performs much worse on a detailed level of reporting. So with that in mind, if you have, let's say, a table with, I don't know, 40, 50,000 rows, and some measures being calculated for each row, you should be better off keeping this low level detail by taking advantage of drill through feature, for example. So display aggregated data in the table by default, and then give a user a possibility to drill through to a specific single row if necessary. If you have a lot of visuals on your report page, consider, and you don't necessarily need mutual interactions between those visuals, such as cross-filtering, you should simply disable that option. Also, sometimes synchronizing slicers, I saw sometimes that also can be performance killer. If you have multiple slicers on multiple report pages and you choose to synchronize all of them, make sure, just check that it's not the reason for the report's poor performance. Okay, storage mode decision. I should maybe place this one in the beginning, as decision which storage mode you want to use is one of the first you are making when you're starting to build your Power BI solution. However, I've intentionally left it for the closing part of the session, and I think I had a good reason for this. I saw a lot of cases, believe me, when someone thought that poor report performance can be improved by switching to direct query mode, and thinking that capabilities of those powerful database management systems that are built to efficiently cope with large amounts of data will solve the problems. That's utterly wrong. I mean, those systems are built to cope with large amounts of data, but in completely different scenarios than direct query for Power BI. Before I explain why you should avoid using direct query, let me first explain what is a direct query at all. So when you choose direct query storage mode for your tables, this means that data is being retrieved from the data source at the query time. And this also means that the data lives in the original data source before, during, and after the query execution. So nothing goes into the Power BI tabular model. Thinking that using direct query storage mode will improve your Power BI report performance is one of the biggest fallacies, believe me. Direct query will never ever improve performance of the Power BI report, period. To cut the story short, you should use direct query literally in 3 and only those 3 scenarios. First one is your data model size is so large that you simply can't import it in Power BI. For pro licenses, this limit is 1 GB per data set. For premium, I think you should not face this issue at all unless you're dealing with really huge amounts of data. Requirement to have near real-time reporting solution. So as you already learned, when you use import mode, Power BI keeps the snapshot of your data. Now, let's say that the requirement is to have the data in the report with maximum 1 minute latency. Obviously, you can't refresh data so frequently to satisfy this request. However, don't fall into the trap if your users request real-time data. First, ask them what is real-time data for them. Believe me, I was getting answers like when I ask, what is real-time data for you? Yeah, I want to have, every morning when I come to my office, that's real-time data for me. So check with them what is the real-time data for them. Is it once per hour? You can refresh data set once per hour. So explain all the downsides of using direct query mode. And from my experience, in 99% of cases, users will admit that maybe they don't really need real-time data. Finally, the third reason to use direct query is when your security policies are defined on the data source side. Because in those situations, report consumers' credentials will be propagated to the underlying data source and security rules will be applied there. If I still didn't convince you to avoid direct query, or you simply must go this way, here is the list of general rules that you should keep in mind in order to get the maximum performance from direct query storage mode. First thing is one huge if. So if you have permissions to perform changes on the data source, there are multiple ways to improve the direct query performance. First, you can create proper indexes to support your most frequently run queries. Also, you should ensure that data integrity is in place. And finally, if possible, create a persistent data objects in the database, such as tables, or even better, materialized views, which will persist all the necessary transformations and calculations. If you don't have access to an underlying database, you can still gain some improvement within Power BI itself. First thing you should do is to avoid complex Power Query transformations, as the SQL code that is being generated by the Mashup engine, it's correct SQL. You will get results that you asked for, but it's not always the most optimal SQL. If you need to use calculated columns, try to push their creation on the source database and keep them persistent in the source database. Also avoid complex DAX measures. As your DAX statement needs to be translated to a SQL, keep in mind that this process can produce expensive SQL queries. Again, whenever possible, do your calculations on the source side. Next one, avoid relationships on GUID columns. GUID is a special data type, unique identifier data type, and Power BI doesn't support this data type. So Power BI needs to do some internal conversions, data conversion during the query execution, which obviously affects the performance. The solution here is to convert this data type within the source database to varchar or some other text data type before Power BI generates its own queries. Also limit parallelism whenever possible. You can define the maximum number of connections that direct query can open at the same time. Also, there are some additional optimization options in the query reduction tab under options in Power BI desktop. Basically, you can restrict slicers and filters. as if you don't do this, whenever you change one slicer value, all the slicers will generate the query to a data source. And finally, also this one is important. You should check assume referential integrity option. Why? Because this will enable, while generating SQL queries, this will enable usage of inner joins instead of outer joins. Inner joins are usually more performant than outer joins, and that can improve the overall query performance. Of course, as a prerequisite, you should have referential integrity in place within your source database, but I hope that's the case, nevertheless, of Power BI and direct query. To conclude, the best practice regarding direct query storage mode is avoid direct query if possible. Okay, so we covered a lot, but maybe I'm a little bit out of time, but let's wrap up the key takeaways from our today's session, or as I like to call this one, Monday to-do list. Today's Thursday, so you can call it Friday to-do list when you come tomorrow to your office, things you can do to improve the performance of your Power BI report. The key thing is to identify which part or which parts of your Power BI solution don't perform well. If your data model size is large, consider removing unnecessary rows and columns and try to reduce column cardinality. For example, by removing time portion from your timestamp columns like you saw in our demo. If your data refresh process takes a while, check if the query folding is happening. In case that you identify the step that breaks query folding and you need to keep it in your transformation process, try to push it down the transformation pipeline as much as possible. Be mindful when you write DAX to enhance your data model with additional columns and measures. For example, if you need to filter the data, filter columns, not whole tables. If your report page renders slowly, try to reduce the number of visuals on it. Use Performance Analyzer to identify bottlenecks and don't use many visuals that calculate single value, such as card visuals, for example. And finally, stay away from direct query storage mode if possible, and use it in only those 3 scenarios that we've already discussed. Now, of course, you should keep in mind each of these points, but if you ask me, one of them is slightly more significant, and that is the number 1. So identifying which part of your Power BI solution is the root of the performance issues will help you to focus on solving this specific problem rather than wasting time investigating less important stuff. That's it for me. You know how they say the road to hell is paved with good intentions. So now that you know what are the deadly sins when it comes to Power BI performance, you may get your redemption by avoiding to commit them again. If any questions, feel free to drop them. I will
back
check
online.
Mm-hmm.
Yeah, brilliant. Any questions, anyone? Yeah, I'll probably have to relay them because it's not like question time with a big mic. Disable data preview, that's the question, yeah.
I'm checking chat window. There are 2 questions.
Tell you what, you answer the chat questions and then we'll come on to the data preview, the
Okay, perfect.
Loading in the background, I guess. Yeah.
So is query folding helpful for the optimization? Yes, of course, it's helpful for optimizing the performance of data refresh process. So it doesn't have anything. So if the report itself is slow, if visuals take time to render, that's not related to query folding. Query folding is related only to importing data into Power BI. Keep that in mind. Yeah, Alex already answered. Sorry, I didn't see the answer. Thanks, Alex. Nimai asked, any say on using import and direct query at the same time? Yes, of course. That's also a good solution for certain scenarios. You can use composite models to combine to leave some tables in direct query mode, some tables in import mode. Usually, the idea is to keep detailed data with many records in direct query mode and to pre-aggregate data and import it in Power BI. So to leverage aggregations basically in these composite models. And this is also this new feature, hybrid tables with basically using imported direct query on a table level. So not on a model level, but on a table level. But that's still in preview. So I will still not rely much on this feature until it goes to general availability.
Hi, Nicola. It is Francisco here from
Hi.
Manchester. Nice to meet you. So I
Nice
have a question related to data preview when you are working in Power Query. So basically, if you are working with queries from BigQuery, you are penalized if those queries are very expensive. If you disable the data preview, will that help with the cost?
You talking specifically about Google BigQuery, just to confirm, if I understood correctly.
Yeah.
Okay.
Yeah.
Honestly, I don't have many experience working with BigQuery, so I can't tell you yes or no. But in general, yes, it should help. It should help.
Okay. Yeah, I understand that every time you jump from one query to another query, it will run another query.
Another query in the background. Yeah.
Okay. Yeah. Thank you.
No problem.
All right, thanks, Nick, for that. I've made a couple of notes, of course, as I do. I've got a couple of Power BI reports which are direct query, and the customers love them because it is near real time, but the data's small. And it always comes down to, doesn't it, a balance between usability and performance. And it's great if you're on the data side and you just say, I need everything to be performant and really performant, but we've got to think about the usability side as well. And you know, our users have to use this stuff. And actually, if you set up direct query, nobody has to worry about a refresh, and nobody has to worry about whether that refresh is broken or anything like that. So everything in life is a compromise, right? I'm only going to have 3 beers tonight before I present, and that's a compromise between what I'd normally be doing on a Thursday night. So, that's it. Distinct count, I think, as well as a DAX measure, is pretty inefficient. You can write your own distinct count, I think, and solve that problem. But I've never had to do it because it's never been a big issue for me. Yeah, but if I got a big enough data set, then I'd look into how to do that. All right, Nick, brilliant. Thank you. Might see you in Salzburg later in the year. I hope to do so.
Hope that. Give me a call, definitely.
We will. I'll buy the beers. I'm going to get rid of you now. If you stop presenting.
Sure. Just thanks for my side, and enjoy Ben's presentation and enjoy the rest of the evening.
Good luck to Barcelona.
Thanks.